All right, welcome back, geometry. Here we are today. We are jumping into a new lesson. We are actually going to talk about the equations of circles. You looked at this just a tad bit on Thursday, Friday after you finish your assessment, which should be in progress book, I believe, if I remember correctly. And so our equation of our circle. So our equation of our circle with the circle centered at the origin is x squared plus y squared equals r squared. So let's talk about what this means. So x obviously is your input of your function, or actually a circle is not a function because if we did our vertical line test, we would be able to pass through at two spots and show that's not a function. So this isn't a function, but it is an equation. So the x is the input of the equation, the y is the output of the equation, kind of. And then the r, what this r stands for is the radius. So once again, the radius of a circle is from the center of the circle to any point on the outside. And if we think about it, our definition of a circle is always going to have the exact same radius from that center to any point on the outside. So from my center to this point over here is going to be the same length. From my center to this point over here is going to be the same length. All of these are going to be the exact same length of our radius, r. So the equation of our circle is x squared plus y squared equals the radius squared. And let's talk about how this came up. So let's say we have our circle centered at the origin here. So we know our center is going to be at 0, 0. If we think about any point on my circle, just any random point, I'm going to say, okay, I have this point xy. Now, xy is some x coordinate, some y coordinate. It doesn't matter what they are, but it's xy. Now, if I were to try to figure out what the radius or how long that radius would be from my center to my outside, I could draw this little triangle here. And I see that this is a triangle because I'm going over x, I'm going up y to get from 0, 0 to my coordinate xy. I would have to go over however much on the x-axis. I would have to go up however much on the y-axis. It could possibly be down because xy could be a negative, or each of those numbers could be negative. So we could actually go left and right, but we're just saying up and over for right now. And that's going to get me to my coordinate. Well, if I were to try to figure out how long r squared is, or if I was trying to figure out how long r is, our radius, I would have to use the Pythagorean theorem. So a squared plus b squared equals c squared. We could do that because I know two of my side lengths, x and y, if whatever those numbers are, and I could solve for r. Well, plugging those numbers in, we would have x squared plus y squared equals r squared. And that is essentially how we get that equation in the circle. Because once again, I could do this exact same formula for any point on my circle, whatever that new xy would be on my circle, and I would calculate the exact same way. Still get that r squared. So x squared plus y squared equals r squared. That's how we come up with our equation from a circle. It's all because of the Pythagorean theorem, which should give you a hint on how we're going to have to solve for some of the things in today's lesson. Is we're going to have to remember Pythagorean theorem, which you guys are already masters of using, so it shouldn't be any concern. So if I have two circles here, and I want to write the equation of each of these circles, all I need to know is what is my radius. Because if I know the equation of my circle when the center is at the origin is x squared plus y squared equals r squared. I see my center is at the origin here. What is my radius? Well, my radius is just the length from the center to the outside of my circle, any point on the outside of my circle. And if I look, this is 1, 2, 3, 4 units long. So this would be x squared plus y squared equals 4 squared. Well, I actually know what 4 squared is. 4 squared is just 16, so I can put this as x squared plus y squared equals 16, and that would be my equation of my circle. We can do the same idea with this other circle right here, this red circle. I see my center is at the origin. I just need to pick a point on the outside. I'm going to pick this one right here because it's nice and easy to count to. And I see I'm going over 7 spaces. So this would be x squared plus y squared equals 7 squared to get my radius. Well, 7 squared is just 49. So this is x squared plus y squared equals 49. And that's the easy equation of my circle when my origin, or when my vertex, when the center, is centered at the origin. Now let's say our circle is not centered at the origin. So we actually have, I'll leave that face down there. We actually have a different equation. It's x minus h squared plus y minus k squared equals r squared. And the way we come up with this is actually, it's the same idea. It's still using that Pythagorean theorem. If I look, I now, in this picture over here, I now have my center at HK. So HK is my center. If I were to try to, in my random point XY, if I were to try to calculate that distance between my HK and XY to get my R, I would have to look, how far am I going over? How far am I going up? Well, how far am I going over is just X minus H. That's our change on our X minus H. How far am I going up? That's Y minus K. If we think back to the very, very beginning of the year, this is the exact same thing we were doing in the distance formula. So this is really just the whole distance formula, which was D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It's the exact same thing. X2 is my x coordinate, x1 is my h coordinate, x2 or y2 is my y coordinate, y1 is my h coordinate. It's the exact same thing. All we would have to do is square this to get rid of our big square, and our distance would be our r. So it would be x minus h squared plus y minus k squared equals r squared. It's the exact same thing. It's just two different ways of writing it. We just have some different variables thrown in there, but they all represent the same thing. So we're really just using that Pythagorean theorem, that distance formula, to find this. So the only difference is when I'm centered not at the origin is that HK is going to be my center. So I just have to subtract those coordinates from the center. Notice that is subtraction though. So I always have to do the opposite of what those coordinates show up at. So let's look at some examples here. So if my center, if I am centered at 2, 3, that means the equation would be x minus 2 squared plus y minus 3 squared equals my radius, which my radius, if I go down from my center, I'm going down 1, 2, 3, 4, 5. So 5 squared is 25. So x minus 2 squared plus y minus 3 squared equals 25. Once again, it's always subtraction. I'm subtracting my center, and then we still square our radius just like normal. Let's look at another example. This one, my center is at -4, 1. So if I subtract those, it would be x subtracting a negative is a positive. So that's like adding 4. So x plus 4 squared. It's always the inverse of what shows up. And then y minus 1 squared equals my radius, which my radius is just 2. And so that would give me 4. Sorry, let me get a drink really quick. Much better. All right, moving on. A circle in the xy plane has the equation x plus 3 y minus 1 squared equals 25. Which of the following points do not lie on the interior of the circle? So I have this circle here. If I sort of like draw my xy coordinate or my xy plane, I know my center, if I sort of think back, it's opposite of what shows up in the equation. So it's -3, +1 is going to be my center. So -3, +1. This is kind of my circle. My radius equals 5. So I have this really crappy drawn circle right here at -3, 1 with a radius of 5. So I need to figure out which of these is not at the interior of my circle. So which of these points do not fall within my circle? One easy way to check this is we can plug in each of these coordinates into our circle. If the coordinates is, if I plug in the xy coordinate, if I get a number greater than 25, I know it's on the outside of my circle. If I get a number less than 25, I know it's on the inside of my circle because I know 25 should be the length that should get me to the edge of my circle. So we can just plug in each of these values and see which of them work. So if we were to plug in -7, 3, we would have -7 plus 3 squared plus 3 minus 1 squared. And we need to see what this equals. If it's greater than 25, it's on the outside of my circle. If it's less than 25, it's on the inside of my circle. So -7 minus 3 is -4 squared plus 3 minus 1 is 2 squared. So 4 squared is 16. 2 squared is 4. So this gives me 20. So I know that 20 is within the interior of my circle. I just have to keep doing this for the other points. Well, 3, -1, if we think 3, -1 is my coordinate, so I already know this one works because it's at the center. 0, 0, if we look, 0, 0 is easily within our circles. If you wanted to check, we could just do 0 plus 3 squared plus 0 minus 1 squared and see if that is less than 25. Well, 3 squared is, and this is -1 squared. Well, 3 squared is 9, -1 squared is 1, which gives us 10. So that obviously is less than. So that just leaves 3, 2. By process of elimination, we can check just to make sure. It would be 3 plus 3 squared plus 1 or 2 minus 1 squared. And let's see what this gives us. 2 minus 1, right? Yeah, okay. 3 plus 3 is 9. Sorry, 3 plus 3 is 6. I promise I know numbers. Is 6 squared. 2 minus 1 is 1 squared. Well, 3 squared is, or 6 squared is 36, plus 1 squared is 1, which gives us a total of 37. 37 is greater than 5, so 3, 2 is on the outside of my circle. So therefore, 3, 2 would be my solution because it's on the exterior of my circle. Easy enough. We just had to plug in our points, see which one was less than 25, less than our radius, and we are good to go. All right, what is the equation of a circle with a radius of 9 and a center at -12, 7? Once again, this is super easy. We're just plugging information into our equation. So if my center is -12, 7, that means I'm going to have x minus -12, which is going to be x plus 12 squared, y minus 7 squared, and then if my radius is 9, 9 squared is 81, and I'm good. What is the equation of a circle with a radius of 6 and a center at the origin? Well, if my radius is 6, I'm center at the origin. I know the origin center is just x squared plus y squared, because if I'm essentially doing x minus 0 squared, y minus 0 squared, which is x squared plus y squared, so when simplified, radius of 6 gives us 36. What is the radius with an equation of 20? Radius of 20 and a center at -6, 15. So it's x minus -6 is positive 6 squared. Y minus 15 is positive 15 squared. And then 20 squared is 400. A circle is graphed on the xy plane. In the circle has if the circle has a radius of 3 and a center of 4, -2, which of the following could be the equation? So we know the radius is 3. So already from our equation, we know because it's r squared, it's not going to be this first one. It's not going to be the second one. It has to be either 9 or 9. And the center is at 4, -2. Remember, it's always opposite. So we should have -4, +2. Are these the exact same thing? X minus 4 squared plus y minus plus 2 squared equals 9. Yeah, these are the exact same. They should be different. One of those should probably be mine. So it's either C or D. There's 2 answers in this one. Sorry about that. Those should be different. All right. What is the center in the radius? Well, my center is, looking at this, I'm subtracting nothing. So my center is at 0, 0, or the origin. My radius is 7. We actually had that one earlier. What is our center and our radius of this one? Well, if I look, it's always minus my x coordinate, which is -5, minus my y coordinate, which is -8, which would turn into +8. And then this, in order to figure out my radius is going to be the square root of 196. The square root of 196 should be 14, if I remember off the top of my head, but I don't. It should be 14. So if we take out our calculator, square root of 196 gives us 14. Yes, it's 14. And we're good. Moving on. Last questions. What is the equation of a circle with a radius at 0, 0, or a center at 0, 0, and a point at 6, 0, 6? So all I know about my circle is I'm centered at 0, 0, and I have a point at 0, 6. So I have this really poorly drawn circle here. Should be a little bit smaller than what is shown there. Well, if I know the center is at 0, 0, I know it's going to be x squared plus y squared. I just need to figure out what my radius is. Luckily, I can see my radius from the center to the outside. It's always going to be the same, so it doesn't matter what outside point I'm using, as long as I know a outside point, which is 6 long, so it should be x squared plus y squared equals 36. Easy enough. Let's look at the second one. My equation of my circle is at -3, -2, and I have a point 1, -5. So rather than giving me a nice easy point to count to, they gave me a point that's at a diagonal. So I can't just count over to this. So in order to figure out my radius, because I still know, I know the beginning of the equation of my circle is going to be at x plus 3 squared, y plus 2 squared equals some number. I know the center part because I know that's -3, -2. But I still need to figure out what the radius is of the circle, because the point they only gave me a point at 1, -5. I don't know what the radius is. So in order to calculate this, all we need to do is either do distance formula or Pythagorean theorem, whatever our two options are, and we can easily calculate that. So if I look using my Pythagorean theorem, I just need to draw my right triangle. I see I'm going from -3 to 1. That's going over 4. From -2 down to -5, I'm going down 3. So this is essentially a squared plus b squared equals c squared. This is 4 squared plus -3 is the same as +3 squared equals my radius squared. Well, 4 squared is 16. 3 squared is 9, which equals my radius squared. 16 plus 9 is 25. So typically, that equals my radius squared. So typically from here, I would then square root in order to get my radius. But once again, in our equation, we're looking for the radius squared. So I can actually just keep radius squared and throw in 25. Square root of 25 is 5, so we know our radius is 5 if needed for other points. But for in the equation, I just need to put the radius squared. So I actually don't have to do that last step. And that is how we can create the equation from our center and another point. You should have some practice over this in a Desmos activity, and then some inspiring practice to finish out the period. Let me know if you have any questions. Have a great rest of your day.